The Fourier transform of a signal x j omega is given, and you have to find there are how many subparts? 1, 2, 3, 4, 5. Yeah, 6 subparts. So can you please try this? If a signal is real and even, then it is real and even, isn't it? Is it the property? If a signal is real and even, its Fourier transform is real and even. If a signal is real and odd, its Fourier transform is what?
Odd and imaginary.
Odd and
Imaginary and
purely imaginary and odd. I think I have. Did we prove that in the class? It is straightforward. I think in the case of Fourier series, we have proved that, and here also it is straightforward. If xt is x of j omega, then the property is that x star t is x star minus j omega. This is the conjugation property. Okay. So from this you can prove that if a signal is real and even, its Fourier transform is real and even, because x minus t is x minus j omega. Okay. If a signal is real and even, its Fourier transform is also real and even. So tell me what is the phase angle of x j omega?
j omega.
What j omega?
Sorry, sir, omega.
Omega or minus omega?
Minus omega.
It is minus omega. How do you get that? Let's say the signal is xt and this one. If you are shifting that signal, let's say x1t is xt plus 1. If we shift this, oh sorry, no, sorry, what is wrong here? Oh no, this is the signal xt, isn't it? Signal is given, so you have to find this. This is not the Fourier transform, signal is given. Okay, so this is signal is real, xt is real. So if you shift it left by 1, that is xt plus 1, this is a real and even signal. Now if you take the Fourier transform of that signal x1 j omega, what is the phase angle of that? What is phase angle of x1 j omega?
0.
It is 0 because this is real means this is also real. Real means phase angle is 0. Okay. Now how the phase angles of these are related? What is the relation between the Fourier transforms? x1 j omega is equal to x what? Into e to the power what?
J omega.
J omega. This is the relation. Okay. Now what is the relation between the phase angles? If this is the relation, what is the relation between the phase angles?
Sum of the phases
Sum
of
of
x
the
of j
phases
omega.
x of j omega and this. So what is the phase? So we can say that phase angle of x1 j omega, that is equal to phase angle of x j omega plus what?
J omega.
Is it j omega or omega?
Omega.
It is omega. Phase angle of this is omega. It is not j omega. So since this is even, x1t is even, this is 0, so 0 is, so this is the question, x of j omega is minus omega, isn't it? Is it? Okay, now.
So in the figure, the figure you made initially, that x of j
No,
omega versus omega.
that was my mistake. It is a time domain signal. Signal is given, isn't it?
If that was the question, then answer would be 0, no?
What?
If the figure for x j omega was given,
No, then
the answer.
yeah, then there is no point in finding this 0 because it is real
Yes.
valued, isn't it?
Yes.
So it is, question is xt is given. Okay, if xj omega is given, then why should I ask the phase? If it is a real valued that spectrum. Okay. Now tell me what is the answer of this one, x of j0. What is x of j0? That means the value of the Fourier transform at omega is j0 means the value of the Fourier transform at omega is equal to 0. What is the expression for Fourier transform of a signal? It is integral minus infinity to infinity xt e to the power minus j omega t dt, isn't it? That is the Fourier integral. Now, if you want to find the value at 0, omega, when omega is equal to 0, put omega equals to 0 here. So this is what? This is integral minus infinity to infinity xt dt. Is it that? Put omega equals to 0 here. Is it? So can we say that xj0 here, this capital X, xj0 is what? Is it the area under xt? Is it that?
Yes, sir.
Okay. So what is the answer?
So 7.
7. Now what about C?
So 2 pi into x of
It is xt is equal to 1 upon 2 pi okay. This is the inverse Fourier integral. Now the question is, what is integral minus infinity to infinity x j omega d omega? So how is it related with xt? Sorry, it is not. Yeah, this is the question. Integral x j omega d. How is it related with xt?
equal to 0.
Is it 2 pi into x0?
Yes, sir.
So x0 is 1, so the answer is 2 pi, isn't it? Is it? Answer is 2 pi. Now, can you try the next part of that question, D?
So for part B, answer should be 3.5.
Part B, answer is 3.5. Is it? 1 plus 1, yeah, it is 3.5. It is not 7. Because this...
Question is given.
Sorry?
Sir, question it is given 2, sir. Height is 2.
Yes, sir. In the question paper, it is 2. The maximum amplitude.
Okay, it is 2. Okay. Now, can you try the next part of that question? D part. Okay. Can you tell me what is the answer?
Sir, xt convolution rect function. Time shifted version of rect function.
3.5.
3.5. Is this in some standard form? 2 sine omega by sine omega. It is the Fourier transform. If this is the Fourier transform of some signal, then what is the signal?
Rect function.
It is a rect function. Is it? And what is the width of that function? Let's say this is some signal x1t. Its Fourier transform is this. It is x1 j omega. What is this width? 1. And what about height? Amplitude of that signal is what?
1.
This 1. This is the signal. Okay. Now can you use some property? This is x1 j omega. So the given integral is integral minus infinity to infinity x j omega into x1 j omega into e to the power j2 omega d omega. Is it? Now can we convert this into some standard integral? What would be this integral? If it is instead of 2, if it is t, then what? What is this?
XT convolution.
Convolution x1.
It is not xt convolution. There is a scaling factor 1 upon 2 pi. This is xt convolution x1t, isn't it? Now if you want to find this t at this one 2, then what is the answer? The answer is what? Is it xt convolution x1t at t is equal to 2? Is it? This integral?
Yes, sir.
Yes. Now, in the question, only this part is asked. So you have to, the final answer is 2 pi into xt convolution x1t at t is equal to 2. Okay, this one. Now tell me, what is this convolution? This is a rectangular pulse. What is the convolution operation? You have to flip this and shift by how much? For finding the convolution at t equals to 2.
2.
When you flip this, you will get this, because this is an even function, and then you have to shift this to 2. So is this the answer? Like this one, multiply with this, isn't it? And what is this point is, so no, this is not. Shift by 2 means, where is the overlap? There is overlap here and this one, isn't it? Is it?
Yes, sir.
So it is something like this, not this one. Multiply these two. Multiply these two, find the area. Is it?
3.5.
3.5. So this will be 3.5 into 2 pi. So it is 7 pi. Is it 7 pi? Is it the answer? Sketch the inverse Fourier transform of real part of, okay, let me take a new page. Real part of x j omega. What is the inverse Fourier transform of, what is the corresponding signal? Can you use some property here? What is real part of x of j omega? Is it x j omega plus x star j omega by 2? Now tell me, what is the inverse Fourier transform of this? What is the inverse Fourier transform of x j omega? It is xt. Tell me, what is the inverse Fourier transform of x star j omega?
Sir, x conjugate of minus t.
Is it conjugate? Yes. The property is that if xt, x j omega, x star t is x star minus j omega, then the other property is that x of minus t is x of minus j omega, isn't it? If we use these two, will you get this as x star minus t by 2? Is it?
Yes.
Now, what type of signal is this? Xt is given. This is xt. Oh, sorry, this one, isn't it? This is xt. Is it a real valued signal? Is xt a real valued signal?
Yes, sir.
So what is this? This is the
even part of x.
it is even part of xt. It is even part of xt. Tell me, what is the even part of the signal? This one plus this one plus this plus flipped version of that. That would be is it sum of these two? Divided by 2. Divided by 2. So the shape of the signal, sum means you are adding 1 to this part, so this will be shifted up by 1, not 1, this is 2, isn't it? This will be shifted up by 2, so the shape is something like this. Is this the even part of that signal? No. No, this is not. Because this is also there, isn't it? Okay, you can find that sum of these two divided by 2. Okay, so I think the shape is this one, and then this one. It is something like this. Is it?
Yes, sir.
You can find these values. So that is the answer.
Sir, in the E part of this problem,
E part we'll discuss.
Won't-
We will discuss later, because that
sir, but won't it be equal to xt convolution x of minus t at t is equal to 0?
that also,
we can
yeah,
write-
that is also true. Okay, but there is a direct property that is called the Parseval's theorem. We'll discuss tomorrow. Yes, you are
Okay.
right. It is you can write it as xt into x star t at t equals to 0. Convolution. Given that mod t e to the power minus t, that is real part of x j omega, this one. And we have seen that for a real, it is given that the signal xt is real valued. It is a real valued signal. So we have seen that for a real valued signal, okay, that is what we proved for the previous question. Even part of xt and real part of x of j omega form a Fourier transform pair if xt is real. Okay. Since it is given that it is a real valued signal, so this is what? Even part of xt. So can we write that xt plus x minus t by 2, that is even part of xt, that is equal to mod t e to the power minus mod t. It is given. Now, the second point is that xt is equal to 0 for t less than 0. If you xt, it is 0 here, isn't it? If it is 0 here, then for x minus t, which interval it is 0? If xt is 0 for t less than 0, can we say that x minus t is 0 for t greater than 0?
Yes, sir.
Now, when you add these two and divide by 2, you will get this, isn't it? Is it? So, what is even part of xt? So, is it straightforward? Xt is 2 into this one. It is t into e to the power minus t ut. Is it?
Yes, sir.
Because it is non-zero, we need to find it only for positive values of t, because it is given that xt is 0 for t less than 0. So for positive values of t, you can remove this mod, and this is to specify that it is 0 for t less than 0. Okay. Okay, any question regarding this tutorial?
So once can you explain the last step?
Which one? This one?
Yes, sir.
So xt, it is given, is this clear? Even part of xt is given.
Yes, sir.
Yes. It is also given that xt is 0 for t less than 0, isn't it? It is given in the question.
Yes,
So
sir.
xt, this part, this one is 0. Okay, this part it is 0. And in x minus t, this will be 0, isn't it? What is even part of xt? Add these two divided by 2. That is even part of the signal. So when you add these two for positive values, only xt will be there, isn't it? This is 0.
Yes, sir. That will be xt by 2, right?
Xt by 2 is this. So xt is
Okay,
2
sir.
into t e to the power minus t.
Yes, sir. I got it. Thank you.
Okay.